Okay, so in this video, we're going to look at a modified Atwood machine again, but what we're going to do is now we're going to incline the surface that the one block is on. So here's our physical picture. All right, so we're going to have a 2,500 kilogram crate resting on an inclined plane, connected by cable to a 4,000 kilogram mass. The second mass is suspended over a pulley. The incline is 30 degrees. And the surface is frictionless. Determine the acceleration of the system and the tension in the cable, right? So here's our situation. All right, where we say M1 is 2,500 kilograms. M2 is 4,000 kilograms. Okay, frictionless surface, which is good, because then we don't have to worry about any effect. So if you think about it, this system will accelerate with the 4,000 kilogram block, right, moving down, which means this block is going to move up the incline, okay? So that's going to help us with our positive direction. Okay, positive X is going to be up the incline, positive Y is going to be down the incline. Okay, so now let's do, so there's just the physical picture. Here's our draw step. Remember, we have to do the free body diagram for both objects. So we've got weight down, normal force perpendicular to the surface, and then tension going up the incline. That's our, and then our positive X, right, following the incline. Here's our hanging mass. So you got the tension up, and then the weight down. Okay, and remember, these two T's are equal, right? Because we always assume massless friction is pulley. Same thing about the string. Okay. So what makes this problem a little bit easier is that we don't have to account for friction on the block that's on the incline. So let's sum the forces, X, Y. Okay, so this is for the inclined surface. So we got sum of the forces in the Y direction, 0. For now, this is going to be just practice because we don't have to worry about the normal force, right? So very typical of the inclined plane, okay, where our normal force is equal to the weight in the Y direction. Now we do the X direction, and this is where our acceleration is. In fact, again, you can just call it A because it's the only acceleration that we have, is what's in the X direction. And so now we sum the forces. We have tension minus FGX. You have to be careful because in the triangle, right, FGX actually points down the incline. Okay, so here's our weight vector broken up, and here's FGX right here. It points down the incline. So tension minus mg sine theta equals ma. Okay, and again, you can use whatever math technique you want to solve this for tension. So it's going to be mg sine theta plus ma. In fact, don't forget subscripts. The subscripts are going to help because so you don't get them mixed up later as to which mass is which. All right, so now let's do the hanging block. And for our hanging block, remember we follow the incline or the string along the pulley. Okay, our positive X is actually going to point down. So it's going to make FG2 minus T equals M2A. Okay, and so if we solve this for T, we're going to add and subtract. So it's going to be M2G plus, or excuse me, minus. In fact, it should be M2A minus M2G. So M2A, no, that's right. Okay, so now I have two equations, both solve for T. Okay, and I can set them equal to each other. So it's going to be M1G sine theta plus M1A equals M2G minus M2A. Okay, get anything with a G to one side, anything with an A to the other. So we're going to have M1 plus M2A equals M2G minus M1G sine theta. Okay, remember I told you what the signature of Atwood machines is? Total mass. There it is right there. Okay, M1 plus M2. And so now we just finish this out by solving for A. So A is going to be M2. In fact, we can clean it up to make it plug into our calculator a little bit easier. Right, just simply factoring out a G into G times M2 minus M1 sine theta over our total mass. Okay, and so now you plug it in your numbers. Let me find my calculator. Okay, so we're going to have 10 times M2 was 4,000, M1 was 3,500, 2,500, sine 30 divided by 4,000 plus 2,500. And so the acceleration of our system is going to be 4.23 meters per second squared. Okay, so there is our acceleration. Now we just plug this into tension, right, to find tension. And let's just do M2. So that's going to be M2 times G minus A. So tension is going to be 2,500, or sorry, M2 is the 4,000. So it's going to be 4,000. All right, so 4,000 times 10 minus 4.23. So it's 4,000 times 10 minus 4.23, close parentheses, and we're going to get a tension of 23,000 newtons. Okay, so the difference between the modified Atwood machine before and this one is that it's on an inclined plane, where if you notice that here, right, we have a sign running around with our first mass, okay? But again, here's our signature of an Atwood machine, right? Atwood machine, you're always going to divide by total mass at some point in time, okay? So in the next connected object problems, and we're going to deal is when they're physically touching, right? So it's not necessarily going to be connected by a pulley, okay?